And welcome guys to another lesson here in CP Finite on the empirical rule. What is the empirical rule and how do you apply it is our essential question. The basic thing to know is we have this new shaped distribution, the bell shape, also known as the normal distribution. And this phenomenon happens to occur in many things in life. For IQ scores, for heights and weights, for a lot of things, the idea is that in general, if you have some mean, data tends to fall within 1 or 2 standard deviations of the mean. Okay, so analyzing this here, this picture is always going to look the same, so it's a good idea to memorize all the percentages. I know it's a little fuzzy on here, but if you need to rewrite it, this is 34%, this is 34%, 13.5, 13.5, 2.5, and 2.5. Okay? Always how it's broken up, as long as you know it's a normal distribution. So if the problem says it's normal distribution, that's what it looks like. Anyway, what is here is, well, the mean is always going to be in your middle. Okay, that is what this value technically is the mean. That's what that symbol represents, the mean or average. Now, the data here means that within 1 standard deviation, plus or minus 1, 68% of our data lies. How did I get that? Well, within 1 standard deviation would be these values here, and it just so happens that 68 is 34 plus 34. 68% of the data is within that range. So forth with 13.5 and 13.5 and going on from there. So if you know your mean and you know your standard deviation, that's all basically what you need to do to fill out some of these problems. So we're going to look at some examples of these here, but definitely memorize how these are broken up. Okay, 34, 34, and so forth. Okay, SATs and scores like that are typically bell-shaped. This example problem here. One year during the SATs, high schoolers scored an average of 490 with a standard deviation of 100. The frequency of their scores is bell-shaped. That must be told to you. Roughly sketch a bell-shaped curve with this information. So the first thing we can label is the average of 490. We know that that number is right in the middle, 490. That's our average. Okay. Standard deviation of 100. What that means is every tick is going to be either 100 plus or 100 minus. Okay, so within 1 standard deviation takes us to then 590 or 390. Okay, so you can use your standard deviation then to find the next piece. If you add 100 again, that means that there were some people in the 690s and there were some people in the 290s. Okay, and then 190 and then 790. Alrighty. Roughly sketch a bell-shaped curve with this information. So that's your bell-shaped curve. Now the percentages are all the same. So just remember, this is 34, this is 34. We have 13.5. We have 13.5. We have 2.5, and we have 2.5. Okay. According to the empirical rule, what percentage of scores should be within 2 standard deviations? It might be best to look at this and highlight this. Within 2 standard deviations means here is 2 from the mean below, here's 2 from the mean above. Okay, all of this is the percentage of scores. So the percentage would be 34 plus 34 plus 13.5 plus 13.5, which comes out to be about 95% of people score within that range. Determine the percentage of scores that are between 390 and 590. Well, this is just identifying from our table here, from our rule. So from 390 to 590 are 34 and 34. So just 34 plus 34, that is 68%. At least, what score must you achieve to be in the top 15? So let's think about this here. The top 15%. Well, the top 15% are going to be within this range here. So top 15, if this is 13.5 and that's 2.5. Okay, top 15% is anyone in this spectrum. There's a little tail end here. So that's all it means, is to be in the top 15%, you need to be beyond 2 standard deviations. So what score must you achieve? You must be at the 590 or above mark. Okay, if a student scored 790 on his test, how do they compare with the rest of the students? So if they scored a 790, that's at the very, very tail end. They performed or outperformed at that point 99% roughly of their peers. Okay, because they are so far along there that they outperform 99%. You could definitely round and say roughly 100, but they are within 3 standard deviations, 790. If you add up the percentages, you're not exactly at 100, so there's always room for a little bit of error from there. Let's just kind of look at another one here. So 5. Say a student scored 590. How do they compare? In this case, so 590 would be about here. They would have scored better than, okay, 34, 34, 13.5, and 2.5. They scored better than 84%. So they outscored 84% of their peers. Okay, that's really about it. Okay, so I'm actually going to move on to the homework problems. I'll actually do a video of me going through those. What I encourage you to do, of course, is pause or come back to these later. I'll have a separate video going through those, but that's the basics of the notes. So get used to the empirical rule, how everything's broken up, and that's really about it, guys. So adding together percentages and so forth. So good luck. Thanks for watching.